Hi, and welcome to the video. So this is the fourth video in a Transformers from Scratch mini-series. So if you haven't been following along, we've essentially covered what you can see on the screen. So we got some data, we built a tokenizer with it, and then we've set up our input pipeline ready to begin actually training our model, which is what we're going to cover in this video. So let's move over to the code, and we see here that we have essentially everything we've done so far. So we've built our input data, our input pipeline, and we're now at a point where we have a data loader, a PyTorch data loader ready, and we can begin training a model with it. So there are a few things to be aware of. So, I mean, first, let's just have a quick look at the structure of our data. So when we're training a model for mass language modeling, we need a few tensors. We need three tensors, and this is for training RoBERTa, by the way, as well. Same thing with BERT as well. We have our input IDs, attention mask, and our labels. Our input IDs have roughly 15% of their values masked. So we can see that here we have these two tensors. These are the labels, and we have the real tokens in here, the token IDs. And then in our input IDs tensor, we have these being replaced with mask tokens, the number 4s. So that's the structure of our input data. We've created a Torch dataset from it and use that to create a Torch data loader. And with that, we can actually begin setting up our model for training. So there are a few things to that. We can't just begin training straight away. So the first thing that we need to do is create a RobertaForMaskedLM config object. And this is the config object is something that we use when we're initializing a transformer from scratch in order to initialize it with a certain set of parameters. So we'll do that first. So we want from transformers import RobertaForMaskedLM config. Okay. And to create that config object, we do this. So we do RobertaForMaskedLM config. And then in here, we need to specify different parameters. Now, one of the main ones is the vocab size. Now, this needs to match to whichever vocab size we have already created in our tokenizer when building our tokenizer. So, I mean, for me, if I go all the way up here to here, this is where I created the tokenizer. I can see, okay, it's this number here, so 30,522. So I'm going to set that. But if you don't have that, you can just write tokenizer vocab size. So here, and that will return your vocab size. So I mean, let's replace that. We'll do this. Now, as well as that, we want to also set this. So max position embedding, and this needs to be set to your max length plus 2 in this case. So max length is set up here. So where is it? Max length here, 512 plus 2, because we have these added special tokens. If we don't do that, we'll end up with a index error because we're going beyond the embedding limits. And then we want our hidden size. So this is the size of the vectors that our embedding layers within RoBERTa will create. So each token, so we have 514 or 12 tokens, and each one of those will be assigned a vector of size 768. This is the typical number. So that's the originally came from the BERT based model. Then we set up the architecture of the the internals of the model. So we want the number of attention heads, which I'm going to set to 12, and also the number of hidden layers, which so the default for this is for RoBERTa 12, but I'm going to go with 6 for the sake of keeping the training times a little shorter. And then we also need to add type, vocab, size, which is just 1. So that's the different token types that we have. We just have 1. Don't need to worry about that. Okay, so that's our configuration object ready, and we can import and initialize a RoBERTa model with that. So we want from transformers. This is kind of similar to what we usually do. Import RoBERTa, and we're doing this for MaskedLM, so MLM, right? So we're training using MLM. So we want RoBERTa for MaskedLM, and we initialize our model using that RoBERTa for MaskedLM object, and we just pass in our config. And that's right there is initialize our RoBERTa model. So that's a plain RoBERTa model, randomly initialize weights and so on. And now we can move on to setting up everything for training. So we have our model. Now we need to prepare a few things before we train it. First thing is we need to decide which device we're going to be training on, so whether that's CPU or a CUDA enabled GPU. And to figure out if we have that, we can write torch CUDA is available. So we write this, and for me it is. So the typical way that you would decide whether you're using CUDA or CPU, or the typical line of code that will decide it for you, is you write device and you do torch.CUDA or torch device, sorry, and then you write CUDA inside here if it's available. Otherwise, we are going to use torch device CPU. Now, CPU takes a really long time. So if you are using CPU, I don't know, you have to leave it overnight for sure, maybe even longer. Even if it's just like a little bit of data, it takes so long. But hopefully you have a GPU. If not, just you're gonna have to be patient. That's all. Or if you could maybe try and use Google Colab, but you have to use the premium version because otherwise it's just gonna shut off after like an hour or two. I don't know. I don't really use it, so I don't know how long it would train for before just deciding it's done. And the GPUs are also not that good anyway. So yeah. However you can do it. And then after that, we want to move our model to our device. So whether it's GPU or CPU, we move over there. We're going to get really big output now. So it's just our model. So this is like the structure of our model. So we can see a few interesting things. We got RoBERTa for MLM. We have the RoBERTa model, and then inside that we have our embeddings, and then we have our 12. Did I say 12? I think it was 6 encoders. It should be. Yeah. So it goes up. It goes from 0 to 5. It's our 6, and then we have the outputs here, and then our final bit, which is the language modeling head, the MLM head. So that's cool. Now we need our optimizer. So from transformers, import AdamW, which is Adam with weighted decay. And what we're going to do is just going to activate the training mode of our model. It's going to give us loads of output again. Oops. So just, yeah, maybe I can let's just remove that. There we go, easier. And then our optimizer is going to be AdamW. We need to pass in our model parameters. And we need a learning rate. So I don't usually use RoBERTa, but looking online, this looks like a reasonable learning rate. I think you can go from sort of here to, I think from what I remember, down to like here. That's the sort of typical range, but obviously it's going to depend on how much data you have, and don't want to do that. How much data you have and loads of different things, right? So that's what I'm going to go with. And that should be pretty much it. So that's our setup. Now we're just going to create our training loop. Now for the training loop, we want to import TQDM so we can see how far through we are. We're going to train for 2 epochs, and we're going to initialize our loop object using TQDM. So TQDM, we have our DataLoader. What is the name of that DataLoader? I'm not sure. Let's DataLoader. Cool. DataLoader, and we set leave equals true. But I need that, sorry, I need that in the same cell. So for batch in loop. And then here we run through each of the steps that we're going to perform for every single training loop. So the first thing we do is initialize the gradients in our optimizer, so 0 grad. So reason we do this is after the first loop, our optimizer is going to be assigned a set of gradients which is going to use to optimize our model. And on the next loop, we don't want those residual gradients to still be there in our optimizer. We want to essentially reset it for the next loop. So that's what we're doing here. Then we want our tensors. So we have input IDs, and that is going to be batch input IDs. And we also want to move that over to our GPU or CPU if you're on that. And this is pretty much the same for our 3. So mask labels, and this is just attention mask. Okay, so we've extracted our tensors, and we just need to feed them into our model now. So we're going to get our outputs from the model. We just do model, input IDs, attention mask, which is going to be equal to mask, and our labels equal to labels. So everything's been fed into our model. We have our outputs. Now we need to extract a few things from the output. So we need the loss. So we write loss equals outputs.loss. And from that, we want to calculate all of the different parameters in our model. We need to calculate the loss for each one of those parameters. So we do this loss.backwards to backpropagate through all of those different values and get that loss. After we've done that, we use our optimizer, take a step, and optimize all of those parameters based on that loss. Then that's everything we need to train the model. And then there's just a few things. So for the progress bar, I just want a little bit of information there, just so I know what's going on. And I just write loop set description. And I just want to print out the epoch. So write that. And then I want to set the postfix as well. So loop.set postfix. And here I just want to see the loss. So we'll just do loss item like that. So that should be everything. Yeah, let's run that. See what happens. Hopefully it should work. No, it didn't work. Okay. Let's see. Oh no, it's a CUDA error. So probably just need to refresh everything. I hate CUDA errors. One moment. Okay, so finally figured it out. It took so long. So a few tips anyway. When you do get a CUDA error, switch your device to CPU and then rerun everything, and you should get a more understandable error. So if we come down here, I've changed it to CPU, and we see that we get an index error. Scroll down, index out of range and self. So the reason for this is, so you get this error if you don't add the extra 2 tokens onto the end of here, but we added them. So I was pretty confused about that. And then it took me a really long time to realize that this argument is wrong and there should be an S on the end. So that was the error. So yeah, super cool. That was literally it. It took me so long to figure that out. But now we have it. That's good. We just need to run everything again. So I'm just going to run through everything, remove this cell here where I change it to CPU because I don't need it now, and just re-execute all that. Okay, so we're back and we've finished training our model now. Now it has taken a long time. This is a few days later. And I made a few changes during training as well. So this definitely wasn't the cleanest training process because I was kind of updating parameters as it was going along. So initially, well, first we've trained for like 3 and a bit epochs, and I've trained on the full data set as well. So if I come up here, I think, do I print out how much data it was? Maybe in another file. So if we come down here, so yeah, there's a lot more data here. So we have 20, let me think, 2 million. Okay, so 2 million samples in that final run. And initially, when we started training, we started with a learning rate of 1e to the minus 5. Now, I looked into this a little bit and it just was not really moving, and I'll show you in a minute. So for the second epoch, I moved it down to 1e to the minus 4, or moved it up, sorry, to 1e to the minus 4. And that, that started moving things a lot quicker. So that was good. And then in total, like I said, it was 3 and a bit epochs. Other than that, I didn't really change anything. The only thing I did was I trained for like 1 epoch at a time because I wanted to see how the results were looking after each epoch. And that was quite interesting. So let me show you that. Okay, so this is after the first epoch. So okay, so here what I'm doing is I've got this fill, which is a pipeline fill object, and I'm entering chow and then putting in now mask and then va. And I wanted to say chow come va, right? And in the middle I want that to predict come. Now this is after the first epoch, and we can see it's not yeah, it's putting like random characters. So question mark here, 3 dots here, chow and chow again here. Kind of weird. So yeah, not the best, right? And then we move on to the second epoch, and it's still rubbish, but at least it's got words, right? So like here we have a word, chow kiva or chiva, chow kiva. I don't know if that's the way. The CH in Italian, I always get messed up. If there's any Italians watching, I'm sorry. Ciao, cosa va? At least we're getting words, but none of these, so it doesn't make any sense. Okay, so no, it's still not good. Now, if we come across again, so this is this one, yeah, this one. Now we get it. So the rest of these are the rest of them are nonsense. Okay, so the 4 here, ignore them. However, at the top we get this score of 0.33, and we get chow va. So that's what we wanted. So that's good. It means it's working. This was after the 3rd and a bit epoch. Let me show you the loss function as well. So this, I know this is really messy. So here we have our, I don't know why this one's so short actually. Why is that one so short? Strange one. Maybe I didn't. Yeah, for the last one, it doesn't look like I finished training for the full epoch, so I thought I did. Maybe something happened. I'm not sure, but fine. It is what it is. That's fine. So the first set of training I did was here, and you can see in the middle my computer went to sleep for a bit overnight because it was so loud. So I turned it off for a bit, and then continue going down. Now this first epoch is when we were at 1 e to the -5, and then here I was testing the 1 e to the -4, and you can see straight away it goes down way quicker. So I was like, okay, we're gonna go with that. It's clearly a lot better. And then continued over here, the next epoch, and then find the final one here, which it didn't seem to change much anyway, but there was still a pretty clear difference. So that's the loss over time, and yeah, I mean we've seen the results from that. So now we have that. Let's move on to actually testing the model. So I'm going to bring Lara in. I'm going to just open the file. Okay, so this is the testing we're going to do. So we're using the file mask. We've got this pipeline. Fill mask. I've got this pipeline, and what I'm going to do is just get Lara to come in, enter some Italian sentences, and just add this random mask token in and see if the results are bearable or not. So let's see. So I will see you in a minute. This is Lara. She can speak Italian, so she's going to go through this and test it a few times and hopefully say it's good. Let's see.
Hopefully. Ciao.
Okay, so all you need to do is we have like a sentence here, and you just write some Italian, and then for one of the words in there, we want to replace it with this text here, and then that's going to like mask that word, and then the model is going to try and predict what is there.
Okay.
And hopefully it will predict. But let's see. So just write some Italian phrase, not too difficult yet, and see.
So I don't have to write ciao va.
No. You just write a sentence, and
okay,
we'll do that.
Buongiorno, gente. No, buongiorno.
Maybe a few words there, not just two.
Okay. Can I put comma or dots?
Yeah, you can put comma.
Buongiorno, come va?
Okay, and then so which word should we cover?
Come?
Okay. And then, okay, so just cover it with the mask and see what it says. So not this. I just need to rerun these as well. Okay, so let's give it a moment.
Chi va?
Yeah, but the second one, come va.
Come va?
It's almost there. Does chi va mean anything? Like who?
Yeah, it's like is there someone? But we like I understand because I'm Italian, but I don't think that we don't usually say that. I don't think.
I'm gonna take that as fine. I'm going to take that as it's good.
So let's do it again, maybe.
Yeah. Try another one. Oh, wait, actually, what about these ones? Cosa va? No. Non va, definitely not, right?
No.
Che va?
No.
No? Okay.
But it just like after buongiorno, I wouldn't expect.
Chi va?
Chi va?
Yeah, but it's okay. So you can just put another one, like where we put fill again. You can write another sentence.
So we're here.
Yeah.
So we can write. Yeah.
Yeah, and then what do you want to replace?
Incontriamo maybe? Or dove as well.
Okay. Yeah. So which one?
You decide, it's fine.
I think Contriano is interesting.
Okay, let's try.
Yeah. Oh, look at that.
Yeah, that's good. Dove ci vediamo oggi pomeriggio? Dove ci incontriamo oggi pomeriggio? Dove ci siamo oggi pomeriggio? No.
No.
Dove ci troviamo oggi pomeriggio? Dove ci ritroviamo? Yeah, that's quite good. Yeah.
That's cool. Okay.
Should we try with dove? Like using the same phrase, but
Yeah. Try it.
changing.
I think you can do it.
Okay.
You can Control Z, right?
Yeah. Okay, let's run it. Dove? The second one. Come ci incontriamo?
Not as good.
Quando ci incontriamo is good. Sì.
That's cool.
Yeah. Cosa? Se. Let's try another one.
Yeah. Go on.
Cosa prepari per cena stasera? Okay. Let's remove prepari. Yeah.
Control V.
Yeah. Go. Run it.
Yeah.
Cosa fare per cena stasera? That's good. Cosa serve per cena stasera? Yeah. Cosa aspetta per cena stasera? Ni.
No.
Cosa succede per cena stasera? Ni. Cosa vedere per cena stasera? Ni. So I didn't find what we said before, which was cosa prepari per cena stasera?
Yeah. But does it make sense?
Yeah, it makes sense.
Cool.
Cosa fare per cena stasera? Cosa serve per cena stasera? Sì.
Can we try something hard, like grammatically difficult?
Cosa succederebbe?
Is it hard?
No, I'm thinking. When it's like that, I don't know. Like, doesn't come to my mind. Cos'è se avessimo scelto un altro giorno? Okay.
Yeah. And then what should we replace?
Avessimo.
How do you say? Avessimo?
Sì. Avessimo.
Avessimo. What does that mean?
If we had.
Avessi. Avessi. Avessero. Not
That's very
the
good.
same one. But...
No, but it's good because avessimo it's for third person plural. It's like we had. Avesse is third person singular. So if he had or she had chosen something.
And what does this actually mean? Cosa?
So what would have happened if we had chosen another day? So the first one, se avesse scelto, it will be the third person. Se avessi scelto, it will be the first person. So if I had chosen another day. Se avessero, it's a second person plural. So it will be if they had chosen another day. Se avete scelto, this one, no. Se avete scelto. Yeah. This is good. Se venisse scelto as well. No, maybe no. But the first three are very good, yeah.
That's cool.
I have an idea. So now if we change to se, so if we put se loro, so if we specify the person, maybe we'll take the correct one.
Okay.
So if we put se loro.
And then we expect it to say avessimo?
Avessero.
Avessero.
Avessero. So let's run it.
Avessero.
You see?
That's cool.
That's very good.
And then the other one's loro anno is right. Abbiano. I mean I'm saying
well the verb is incorrect, but
yeah, it's in the wrong place, but it's saying the right.
Like the meaning is correct.
Yeah.
But the grammar it's not correct.
Okay. Right. Okay.
Yeah.
Oh, it's cool.
You're
I'm
welcome.
happy it actually worked because I wasn't sure. I thought you could just it worked with child coming back, but that was all I tested it with. So I was a little bit worried that it might not do anything else. But thank you.
You're welcome.
That's
Bye.
That's it. Okay, so I think that's a pretty good result. So, I mean, that's pretty much everything we needed for building our model, our transform model. Although I do want to, so we're going to do one more video after this, where we're going to upload our model to the Hugging Face Model Hub. And then what we'll be able to do is actually download it directly from Hugging Face, which I think will be super cool to do that and figure out how we actually put all that together. So yeah, I think good result. I'm pretty happy with that. And thank you for watching. And I will see you again in the next one.